This is Rational Functions Part 2. We are still trying to find all the asymptotes, intercepts, and additional points so that we can graph these rational functions. So we will start by finding our vertical asymptote. I always go in the same order every time so I remember everything. To do that, I set my denominator equal to 0, and there's nothing to solve, so I just have x equals 0. I next find my horizontal asymptote. That's when I take my degree. I have a 1x squared on top, but I do not have an x squared term on the bottom, so I have to put 0x squared. So 1 divided by 0 is undefined, so that tells me that there is no horizontal asymptote. That means in a minute I'm going to have to divide to find a slant asymptote. But before I do that, I'm going to find my x-intercept, which is when I take my numerator equal to 0 and solve. So I add 1, and then I'm going to take the square root, and when I do that, I get plus or minus 1, which gives me two x-intercepts, -1, 0, and 1, 0. Then I need to locate my y-intercept. And my y-intercept I locate by putting zeros in for all of my x's. So I end up with -1 over 0, which also is undefined. So that tells me that there is no y-intercept. Okay, so as we mentioned before, we're going to have to do some dividing because there was no horizontal asymptote. So I'm going to take x and divide it by x squared minus 1. Now I notice that I have an x term missing, so I'm going to put a 0x as a placeholder for when I'm dividing. So x into x squared gives me x. I'm going to multiply x squared, and I'm going to subtract. That gives me 0, so I bring down the 0x minus 1. And I'm already done dividing because x can't go into 0x. So my remainder is -1, but remember we don't care about the remainder when we are doing slant asymptote. All we care about is this value on top. And so we would say the slant asymptote is y equals x. If we go back to the idea that that's in slope-intercept form, we would have a slope of 1 and a y-intercept. Since it's not there, that plus b would be 0, 0. Now notice that is the slope and the y-intercept of the slant asymptote, not of the graph, because we already said that the graph itself does not have a y-intercept. So these are two different things. Do not get them confused. Let's put on our graph what we have here. X equals 0. Is a vertical asymptote that is really on top of the y-axis. I'm going to put it next to the y-axis just so we can see it. Then we have x-intercepts at -1 and +1. And I have a slant asymptote at y equals x. So that slant asymptote will go through 0, 0, and then up 1 over 1. So this is the path of that slant asymptote. Asymptotes are always dotted. And then we need to find some additional points. 2 on either side of the vertical asymptote, 2 to the right, 2 to the left. So our vertical asymptote was at 0, so I need to go -1 would be my first stop, but I already have a point there. So I'm actually going to go to -2 and -3. Likewise, on the other side, I need to skip over 1 and go to 2 and 3. So -2 is -1.5, -3 is -2.7, 2 is 1.5, and 3 is 2.7. All right, let's graph all of those. So we have -2, -1.5, -3, -2.7, 2, 1.5, and 3, 2.7. So I'm going to use those points along with my asymptotes to get my 2 branches. So I'm going to use this vertical, go along, go through those points, and then down along the slant. And again, my vertical through the points, and then along the slant. Lastly, I'm going to do my domain and range. So I'd say negative infinity to 0. That's where my vertical asymptote is, and it doesn't cross that. But my range goes from negative infinity to infinity. There's no horizontal asymptote stopping it, and no breaks in the graph that stop it either.